once again, this is Tenwa Bashir, a teacher of Gashwaga's Academy. I would like to take you through this example on application of Kirchhoff'S law. We can solve it. We should find I1 and I2, and also we should find the voltage across the V2 battery. So what we are going to do is to apply the Kirchhoff'S rules. So we shall start by applying the junction rule. Now when you look at this circuit, a current I3 is coming and passes through the 4 ohm resistor to meet at this junction here, and when it meets here, it divides into I1 and I2. So we can say that from the junction rule, 2 amperes, that current is going to be equal to I1 plus I2. So this is our first equation. Then now secondly, we look at the voltage rule, whereby we have to draw loops. So we should have a loop here. We can have one. That is our loop, for example. In this sense, that is our loop. So we should call this one loop 1, and we shall have loop 2 here. But let us start with loop 1 for convenience. So for loop 1, let us give it direction. That's its direction, that's its path. Yes. So from there, we are now going to apply the voltage law. So the voltage law says that the total sum of EMFs should be equal to the total sum of potential drops, IR. So the EMF in loop 1, there is only one EMF, which is 18 voltage. When you look at the direction of the loop, is towards the right, and even the source of EMF, it is coming from negative to positive, meaning that EMF is positive. So we should have total of 18 voltage being equal to, there is only one EMF, being equal to the IR, or potential drops. So when you look at this here, R2 or 4 ohms, it is, the current is 2A, 2 amperes, I3. So when you look at it, we should have 2A times 4 ohms. And since when you look at the current, it's flowing towards the left, and also the loop is towards the left, so both are in the same direction. So we are taking that to be positive current. This current is positive. Then after that, we should add on here, current is in that direction for the 7 ohm resistor, or R1, and the loop is in the same direction. So that means we have positive current being positive. So we have 7I1. So when we simplify this, we should have I1 as 10 out of 7 amperes. That is I1. What is I2? So when we go for I2, we should have I2. For I2, we are going to also draw a loop here. So this is our loop. We should give it direction. You give the directions the way you want, but they should be continuous. So this is our loop 2. So for loop 2, the total EMF is V2. Since it is from negative to positive, that is what the direction of the loop is showing us. Then V2 is positive, is equal to total potential drops. We have this one, 4 ohms, and I3. So also positive, because the loop is in the same direction as the current. So we should have 2 times 4, then plus, when we come to this resistor here, its current I2 is towards that side, and even the loop is towards the same side. So that means even the current I2 is positive. So we should have 3I2. Then from there, we should have V2 being equal to 8 plus 3I2. Now what is I2? Remember, from this equation here, we have 2 being equal to I1 plus I2. So that means we should get I2 by saying that I1 plus I2 from equation 1 to be equal to 2. But I1 is 10 out of 7 plus I2 should be equal to 2. So that means I2 is equal to 4 out of 7. 4 out of 7. That is I2. So this is the current I2 flowing through the circuit. Then now what is V2? So from the equation for V2, which we have as V2 is equal to 8 plus 3I2, equation 2, V2 is equal to 8 plus 3I2. So V2 should be equal to 8. Then we should substitute I2 as 4 out of 7. So when you substitute I2 as 4 out of 7, then you come up with V2 being 9.714 voltage. Or if you took it in fraction, then it should be 68 out of 7 voltage. Thank you very much. Hope you followed very well. It is really enjoyable.